Laval is a city of a little bit more than 400,000 inhabitants. And Laval is the population is growing rapidly. Our transit system is what I can call a mid-size transportation system with close to 900 employees, more than 300 buses. One of our main objectives is to increase our ridership. And we did in the past a lot of things to increase our use of technology. About 1 out of 5 people use the transit system in the rush hour morning. It's an increase of about 30% over the last 8 years. All our surveys say the same thing. People need punctuality, people need good information, people need reliability, people need speed. So with TSP, we address all these subjects. So we are very confident that with this system, we'll be able to increase our modal share. With this project, we are expecting to decrease the greenhouse gas effect by more than 30,000 metric tons. So it's a huge impact on environment.
The functioning of the system is simple. As a bus approaches an intersection, if it is running late, it will send a signal that can adjust the duration of the green or the red light by a few seconds to allow the bus to continue its route without having to stop at the traffic light. If several buses approach an intersection at the same time, the one carrying more clients will have priority over the less crowded ones. To be able to do this, we use the conditional and relative priority features offered in the Opticom system. With conditional priority, we can request a priority only when the bus is behind schedule. On top of better respecting our schedule, we'll also be able to reduce the variability of our travel time and ultimately improve our service. The relative priority will maximize time saving by using live passenger counts and delays to determine which vehicle has the highest priority when 2 or more late buses approach the same intersection simultaneously. The CMS data are very useful as they allow us to evaluate how the TSP perform. The CMS records all communications between buses and traffic lights, such as check-in and check-out times of the intersection zone, as well as requested priorities and green sense information. The pilot project we did in 2013 showed really good results. The time saving were between 8 and 10% for the morning peaks, so we anticipate good results with the current project. By combining the Opticom data, we can accurately quantify the impacts of the TSP on our operation and users. The STL has built all the diagnostic tool itself. For example, with one of the reports, we can compare 2 periods of time in order to see the effects of TSP on our travel time, or even a change in controllers programming made by the city. Another report cut out the information of a trip to find how much time we spent waiting at a traffic light or boarding people instead of driving. The experience was very positive. GTT has treated us as a customer but also as a partner. The GTT team assisted us professionally throughout the project. The distance between the technical team in Minnesota was never an issue. The local representative was always present and above all very proactive in the search for solutions that could meet our needs. I'd definitely recommend GTT to other cities and transportation agencies.